This is chapter 8.2, exercise 1 through 10. This section has to do with ellipses, and I'm going to go over the odd number problems in the set 1 through 10. In exercise 1 through 6, find the vertices and foci of the ellipse. And in these exercise 1 through 6, we're going to be dealing with no displacement of the x and the y, meaning that we're talking about the center of the ellipse being the center of the coordinate plane. So I'm going to go ahead and make a sketch as I go here, and I have kind of an XY plane going here, coordinate plane, XY. And what we have here, this is in the standard ellipse, and it is in this form: x squared over a squared plus y squared over b squared are equal to 1. And what a is, and the larger number than b, if a is larger than b, we say a equals the semi-major axis. In other words, that's going to be half of the axis, of the major axis. And b here is what's called the semi-minor axis. Minor axis. And in this case, we have a squared if we take the square root of a squared, we have a is equal to, let me say, a squared equals, I want to write that, a squared is equal to 16, right? And 16 we get from up here, right? A squared is equal to 16. And so therefore a is going to be equal to the square root of 16, which equals 4. Now, it's not going to be plus or minus 4, because in geometry, in distance, we only use the positive for distance. And so the semi-major axis is the longer one, so it's going to be 4 on either side of the y-axis. So -1, -2, -3, -4. So these points here I'm drawing in now, let's see, red, represent the far extremes of this ellipse. And then, not that it's asking for in this problem, but b squared is equal to 7. So b is equal to square root of 7. And that's going to be our semi-minor axis, and square root of 7 is between 2 and 3. So we have here 2 and 3. Okay. So just estimating, it's going to be about right here. So if we draw out the ellipse, we're going to see something like this. Okay, goes up here. It's going to have sort of an oval shape. There, it's better on the left side than on the right side here. Better on the right side than on the left side. So your ellipse is going to look something like this. Okay? Now, to find the focus, or foci, it says here, is c squared equals a squared minus b squared. And in this case, c being the focus, or the distance that is the focus from the center. So in this case, we know a squared and b squared, so c squared is equal to a squared is 16, and b squared is 7, so c squared equals 9, and therefore c is equal to the square root of 9, which is 3. And it's going to be actually a plus minus 3, is it not, in that we're going to the left and the right. So I'm going to draw the foci there here in red. So there we have them. So let's go put the coordinates first for the endpoints of the ellipse, and those endpoints are going to be endpoints. They're going to be the coordinate pairs, -4, 0, and also 4, 0. And for the foci, they're going to be -3, 0, and also 3, 0. So those are the values we're looking for in problem number 1. Next on our problem, which is 3. Now this time, what we have is our major axis is related to the y. And so we will say this is going to be, we can say a squared. A squared equals 36. Therefore, a is equal to 6. And then for a minor axis, we'll say b squared is equal to 27. And so b is going to be equal to the square root of 27. That's the semi-minor axis. That's going to be a little bigger than 5. So just kind of getting out our sketch here. Okay, we draw our xy coordinates here. One straighter. It looks more like this. There we go, a little better. Okay, this time related to y is our semi-major axis. So we're going to have to go up. Our semi-major axis is 6, so we're going to go 1, 2, 3, 4, 5, 6, -1, -2, -3, 4, -5, -6. And then as far as the semi-minor axis, we have the square root of 27, so that's going to be a little bigger than 5. Square root of 25 is 5. So -1, -2, -3, -4, -5, +1, +2, +3, +4, +5. And so our ellipse is going to look like this. Okay. And just drawing an ellipse is going to go like this. Now, this is one that's going to be a vertically oriented ellipse in that it's going to be slightly elongated toward the vertical, as opposed to problem 1 where we had the elongation occurring along the y-axis. And so for this one, we say our endpoints are going to be this one on top, 0, 6, and also 0, -6 at the bottom. So again, the endpoints here are going to be along the y-axis, as opposed to problem 1, or in contrast to problem 1, where we had our endpoints along the x-axis. Okay. Now, for the foci, right? Okay, for foci, we have c squared equals a squared minus e squared. In this case, we have c squared is equal to 36 minus 27. So c squared is equal to 9. Therefore, c is equal to 3, square root of 9. So, just going ahead and putting the foci, we go up here, plus 3, and then down 3. So, we say for foci, we have 0, 3 and 0, negative 3. Okay, so those are the key values. Again, I think problems 1 through 4 are all with equations in standard form. In problems 5 and 6, we have a slight deviation in that we are not given equation in standard form. So what we have to do is the standard form is going to be the equal to 1. So in this case, it's going to be pretty easy to do. If we go ahead and divide both sides of this equation by 12, we're going to be able to get our ellipses, the equation in standard form. So we have 3 over 12, x squared, that's going to be 1/4 x squared, so we're going to have x squared over 4 plus 4/12 is going to be 1/3. All right, so we're going to have plus y squared over 3 is going to be equal to 1. And so our semi-major axis is going to be defined by taking a squared is equal to 4. So a is going to be equal to 2. And for our semi-minor axis, we're going to have b squared is equal to 3. So b is going to be equal to square root of 3, which I think, is that going to be about 1.7 something? I think it is. But in any case, we make our little drawing like I did for problems 1 and 3. Not that's 100% necessary, but I like to do it if possible. So we have 1, 2 on the right, 1, 2 on the left, and up we have 1, 2, and down we have 1, 2. And our semi-major axis is 2, which means we'll go, our endpoints are going to be 2 to the left of the center, the origin, and 2 to the right. And so we say our endpoints are going to be -2, 0, and also two, 0. Okay, so those will be our endpoints. And as far as our rest, we have square root of 3. Well, square root of 3 is going to be about 1.7, I believe. Is that right? Yeah. So this is basically what's going to be looking like. It's going to be like problem 1, a kind of horizontal oriented ellipse with the endpoints along the x-axis. Not very geometrically accurate drawing, but enough. And so for the foci, we say we have c squared equals a squared minus b squared. So we say c squared is equal to 4 minus 3. So c squared is equal to 1. So c therefore is equal to square root of 1, which is 1. And so now we can just place, there we go, the foci I'm just marking right there. Looks almost like a little face. Okay, so we say for foci, we have -1, comma 0, comma 1, comma 0. Again, we box in these answers as correct. And, okay, there we go. Okay, this one here, 36. I think we're going to have a vertically oriented ellipse, which is divided by 36. Okay. Next side symptoms that match the graph with its equation, given that the ticks on all axes are 1 unit apart. So this is one where we're necessarily going to have to do pretty much all of these. So if you look at 7 and 8, 7 and 8 are both in the standard form where you don't have x or y shifted at all. And so for numbers 7 and 8, your choices are going to be C and D necessarily. And what we have in problem 7, if a squared is our semi-major axis, a squared is 25, well, our semi-major axis is going to be square root of 25, which is 5. And that's going to be occurring along the x-axis. So we have +5 and -5 in answer D. And then for our semi-minor axis, it's going to be the square root of 16, which is going to be it's going to be 4 up and 4 down. So definitely our answer choice, the correct graph is going to be graph D that goes with number 7, equation number 7. Next, 8. Well, just kind of by process of elimination, we have a vertically oriented ellipse, and a squared is going to be 36. So the semi-major axis is going to be 6. We have 6 up, 6 down. And semi-minor axis is going to be 3, which is square root of 9. So to the right, to the left, 3. So C is going to be our correct graph for our equation in 8. And so we just have 2 more to deal with. This one here, 9, we have y minus 2. Well, this minus 2 shifts up 2 units. And this x plus 3 shifts to the left 3 units. So based on that, our only possibility is going to be ellipse A. And furthermore, to analyze further, if we have our semi-major axis is going to be square root of 16, which is 4. So we have from the center here 4 up and then 4 down, so that makes sense. And then we're going to have 2, our semi, on either side of our center here. And by process of elimination, B is going to have to be our answer for problem number 10. And what this is going to be a downshift of 2. That's going to be a semi-minor axis of 1, right? Because we're going to have this over 1. So B squared equals 1. And so our height of this one is going to be square root of 11. So anyway, that's all of our odd number problems, including 8 and 10 in this set. Good luck on even number problems, and thanks for viewing.